And I can do other ones too. That's just the one that jumped out at me. Alright, so for 11, we've got triangle, base, area, height. So I need a formula that relates area of a triangle, base, and height. So that is area equals half base times height. And then I got to take the derivative of that. This is going to be a product rule problem. So I don't know if that's like one people forgot right away. But I would rewrite this as like 1/2 times BH, I think, like that. So the 1/2 could just kind of chill on the outside. You do the product rule with this part. Then plug the 1/2 back in. So the derivative of A is dA dt. 1/2 is chilling on the outside. And then fig plus give. So the derivative of B, dB dt, or the change in the base. And then H. And then B times the derivative of H, which is dH dt. And then I can start plugging in things I know or I'm looking for. What do I got here? If the area is increasing, so if the area is increasing, what does that mean has to be true about dA dt? It's got to be positive. The change in the area has to be a positive number because the area is increasing. So that'll come in at the ends. dB, so the change in the base. Well, the base of the triangle is decreasing. -0.2. H, the height is what I'm looking for information about. The base is 3. And then dH dt, the height is increasing at 0.1. So I get that. And what I know is this stuff here has to be greater than 0. It has to be positive because I know that the area is increasing. So basically I've got to figure out, I've got to solve that inequality. So I would just double the entire equation first. Because if you double this side, you know, the 2 and the 1/2 cancel out, and I'll just have -0.2h plus 0.3. Doubling 0 does nothing. So I get to there. And then, how much you guys remember about inequalities? But -0.2h plus 0.3 is greater than 0. So I'd subtract 0.3 from both sides. -0.2h is greater than -0.3. And then I divide by -0.2. Hopefully you remember that when that happens, you switch the sign. When you multiply or divide by a negative number, you switch the sign of the inequality. Then a negative divided by negative is positive. So I get h has to be less than 1.5, which is t. So last, I don't know if you're watching the video, but you asked Will for 4.6 number 11. I think you meant 4.5 number 11 because 4.6 doesn't have 11 questions. So hopefully that'll help. Incorrect. Is that alright? Anyone else on 11 or any other ones on that section? Okay. Alright, let's go to 4.6 then.
Hello,
There's
calculus
like one part of the video that I really liked what he did, because I can't really do it with the zooming ability.
would be an approximate.
So I'm going to just kind of show you on his video. So I'll start writing in the notes in a second, but the idea is we're going to use, like, let's say that we don't know the equation of this. Like, I don't have this, and I don't have a list of values. But I do know the derivative. I know the slope, or I know the velocity, the rate of change. What I'm allowed to do for an estimate is find, like, let's say I wanted the value of the function. You can just zoom in way better right here. I want the value of the function right there. but I don't know it. So what I'm going to do is find the equation of the tangent line, plug this x value into the tangent line, and it's going to get me like pretty close, right? It's not going to be exact, but it's going to be like close-ish. And in this case, would my line or this dot underestimate or overestimate the true result? Underestimate, because it's supposed to be up here, but this line goes underneath the curve. But the idea is we're trying to zoom way in and use I don't know this.
Here, that would be an approximation.
As a way to that was awful. Anyway, okay. So I'm going to try to use this line as a way to estimate points
on this line,
even though I can't see what they are. When you're doing that, so I can do it over here as a different example. Concavity means which way it's curving. So concave up looks like a U. Like it literally looks like the U in the word up. It's going to bend upward. We get way more into this in chapter 5. But today we're just like, I'm just going to basically tell you it's concave up or concave down, and then you go from there. If it's concave up, that line is always going to be below the curve, right? So anytime your original function is concave up, if we're using a line, it's going to underestimate it. So this will be an underestimate because the original is concave up. So it's always like curving up, and I don't take that curve, so I go lower. Concave down is the opposite, so concave down is bending or curving down. Looks like the N. Concave down. And if I do that same like type of line, I didn't draw it great, but that's always going to be like above the curve, right? So again, I want to know, like I know this, I want to know maybe that over there. I use this curve to estimate it, but the line to estimate it, but the line's going to go way on top of what it's supposed to, right? Because the curve is going down. So when the curve is concave down, our line is going to be an overestimate. And for now, that's all you need to understand about concave. So let's look at, this is a good review of tangent lines, too. Okay, so F is concave up, and then they give me, this is like the original X value, the original Y value, that's also the X value, that's the derivative, so like F prime. And from there, I can build my equation of a tangent line. I'm kind of remembering from last year. Is that a 2 in your books? It's a 4? Okay. All right, so equation of a tangent line. So I'm going to go y equals blank, x minus blank plus blank. I'm going to plug it. They basically gave me that information. So the x value is 4. There, the y value is 5, it goes there, and then what goes here is always the slope, which is the derivative, right? The slope and the derivative are the same. So what number goes here? Is 3. So I don't know the original equation, I don't know the original graph, I don't know really anything else about the original except that one point they told me. So all I know is I've got a point at 4, 5, and it's concave up, so it's curving up. I'm using a line to try to estimate what happens at 3.8, which is like over here somewhere. So is my estimate going to underestimate or overestimate? Under or overestimate? My line is going to underestimate it, right? Because it's underneath the curve the whole time. Which is part B, I guess. So for part A, all you're doing, this is your tangent line. You plug 3.8 in. So what's 3.8 minus 4? Negative 0.2 times 3, negative 0.6, and then plus 5 would be 4.4. So the true value is a little higher than 4.4, but But the best I can do with this information is to say it's 4.4, and then yet understand that that's an underestimate because the original graph is concave up. You said it way too many times. It's not custom. If the original function is concave up, your linear approximation will always be an underestimate. Fair enough? I know you're bad enough. But there's a purpose to my jerkness. Question on one, or any other question on one? 5 minutes, I got more. Alright, 2. Same idea, you just gotta do a little more work to get to it. So they tell me concave down. And they give me just the x value this time. So I got a little extra work to do to find the equation of my tangent. So I know that's 1. They give me the x value. What goes here is the y value, right? They didn't give it to me, but I can just plug 1 into the equation and get that. So that's 5 times 1 minus 2 times 1 cubed minus 2, which is 5 minus 2 minus 2, so 1. And then what goes in that slot? That was a terrible error. I was thinking about something else. I want to know what year. I have. What? Yeah. Okay. I have a question for you guys, but I should probably finish the problem before I interrupt my own notes. So the derivative is, what goes here is I got to take the derivative and plug in 1, right? So the derivative is 5 minus 6x squared. And my job is to find the derivative at 1. So I plug in 1. You said it was negative 4? Oh, negative 1, okay. So negative 1 goes in that spot. Good on tangent line? So then the estimate, we just plug negative 1, or sorry, plug 1.1 in for x. So 1.1 minus 1 is 0.1 times negative 1. So negative 0.1, negative 0.1 plus 1. So that'd be 0.9. And is that an underestimate or overestimate? That's an overestimate. How do we know that? Because the curve is concave down. Question on 2 there. So here's my question. I'm like terrified to like cold call on people and be like, Parker, you tell me how to do this. If you say I don't know, like there's teachers I think that'll be like, no, you're gonna figure this out with me. You're gonna talk to me. Do you know what I'm talking about? Where teachers are like, is that beneficial? Not beneficial? You like it? Hate it? It's terrifying, and does it help? So, like, I just ask, like, general questions, and people just kind of shout it out. That's... Yeah, so, like, some teachers, I think, would say it makes them pay attention. But... Yeah, no, like a mental health cost, yeah. That's fair. I was just curious. Okay. Like, when I was in high school, I would have hated that. I would have been terrified. Anyway, let's do number 3. You guys just confirmed what I thought. Who's what? Carter. Talk me through number 3. Oh, that's too bad. You got not off the hook. Let's do it. We'll do it together, buddy. Okay. That's like part of the shtick, though. Yeah. So, tangent line. This one is a little different because what you're given is, I'm trying to see how I can make you notice without telling you. What's different about the equation they gave you in 3 compared to 1 and 2? Emma? What? It's already the derivative. So when I plug in to this, I'm going to get the slope point, right? Because that's the derivative, that's the slope. They gave me this to tell me, like, that's your x, that's your y. So 2 goes here and 0 goes here. Actually, you don't even need to write the 0. But I'm still stuck on this. Is there anyone that like doesn't mind if teachers cold call? Like you don't hate it, you just kind of like whatever, it's fine. What? Only if you're like super confident in your answer. Okay.
So you should just be able to raise your hand or all that.
You should ask if anyone want to try this problem, and then if someone wants to, they'll raise their hand. But if not,
Yeah.
just go.
Like when I do that in class, it's the same person like every time. So
Yeah, it's always good.
yeah, I'm not gonna cold call people. I'm just curious because I've seen it lately in other classes. And anyway, I can't say that. Yeah. Okay, so I gotta find the slope. That's my derivative. Derivative is slope, so I'm just gonna plug in. So this will be e to the y, and y is 0, times 2x squared, x is 2, minus 5x, so minus 5 times 2. So what's e to the 0? 1, so that's not going to matter because you're multiplying by 1. And then this is 8 minus 10, so negative 2. What if it was a normal line? What would that be? Positive 1/2, right? So that's my tangent line. And then use the tangent line to approximate. All you're doing is plugging in. They didn't even ask you if it was over or underestimate. They didn't even tell you concave up or concave down. What are we doing here? So what's 2.2 minus 2? 0.2 doubled and made negative is negative 0.4, then adding 0 does nothing. I don't actually know, but if this is concave up, then am I overestimating or underestimating? Under, because the line will go under the curve. And if it's concave down, the line goes over the curve, so you're overestimating. What's up? I mean, or you could like understand. All right, so you guys got time to work. I don't know how these are going to go. They could be easy. It could be. See. So in 5 minutes, I want Jessica, you're going to explain number 1 on the board. Izzy, you're going to explain number 2 on the board. And everybody.
It still works.
Oh, it's over there.
Let me know if I can help. Check your answers.
That was you.
These are mostly calculated. There's like 2 facts. We get that later.
Because right now, not all.
So do you remember how to take the derivative?
Yep.
Set up.
You definitely don't have to. I got 1.79.
First one. That's one.
After you close it,
should get the slope.
Oh, then you have to plug in a number. Like it's way easier to subtract this unit. Yeah, that is weird.
Right?
Okay, so now we're gonna say before we close the parentheses, hit comma else. You got to look up the one there. That was there.
Carter's favorite.
Close parentheses. Okay, so now there's a few things. Hit that vertical bar. Then type x equals 3, which is what 3 hours after. And plug it in. So funny. In theory, it's going to take the derivative and plug in 3 or 4.
Hour by hour.
So there, I touched one of the things. So I sit there and it goes to the so when I learned from Aristotle, fit diamond and then enter.
That's like, this is x equals 5 too. I don't know. So you why is it? No.
So that's your answer.
I'm saying it's not. Right. It's.
And then it would be, you know, the units on it.
Oh, because it's. Yes. I would do that.
So aid, this is miles per hour, so what level are we really at? We're at velocity, right? Now so that's going to be down to acceleration. So my units will be miles per hour squared. You're going to do the same thing. You're like, I'm going to take the derivative of this. Vertical bar, x equals 2. And then it'll tell you the answer. Yeah, if you can't get it like typed in or anything. This here? Usually stuff laying around with it. Jeez. What do you prefer? So I was telling you, we've done different topics. Yeah, tell her I said that. I would like, she wants. But it just doesn't make sense.
I'll give it to you.
Oh, that's fine.
But we talk about it.
Elsewhere, you just have to I need to already made it. That's not basic. No, but I do see it.